formula that I'm going to give you that you need to memorize, and that's going to be coming down later when we talk about spheres. All right, surface area of a sphere. But all the volumes, everyone see them on the left-hand side, prisms all the way through pyramids. Every formula is given to you. I am not going to have any sympathy, not that I do anyway, if you get a formula wrong. Okay, it's on the darn formula sheet. Okay, it's right there for you. You'll have it on next Thursday's quiz. You'll have it for the Regents exam in another month. All right, all the volume formulas are there for you. There's only one formula that you're going to have to memorize in this part of the unit, and that's it. All right, so it's all there for you. Bad news for this second part, the questions are going to get a little tougher. It's just not going to be finding volume. It's going to be doing something with the volume. You guys that took the quiz yesterday, you had that painting question with how many paint cans do you need to purchase? That's the type, all problems are going to be like that now. Okay, all the problems. All right. So let's just hop right into it. We got a busy day here. I got a busy day of calling on people too. Let's start with today's going to be prisms and cylinders. Figures we're familiar with, but now we're going to find the volume. And just to make sure we're clear on what's the difference between what I had you find for the quiz, surface area, and what I'm having you find now, volume. If I take my cylinder right here, right, the surface area was everything around it, right? Now I'm going to take it and I already did this last period and fill it up. All right, how much water can be contained in the cylinder? That is volume. Okay, so now instead of being on the outside, we're going to be on the inside of the figure. All right. So volume of a prism, you can look on your formula sheet. It's already there. I don't need to give it to you. It's already there. Volume of a prism, it says general prism there because, again, it could be right, triangular, rectangular, a cube. BH, that's what it says on your formula sheet. Let me get a little more detailed here what the capital B represents. We just saw for surface area, the base could be any figure. Could be triangular, hexagon, could be a square, a rectangle. Big B, capital B, that's the area of whatever the base is. That's what we plug in for capital B. It's the area of whatever shape the base is in. So if it's in a rectangle, we do length times width. If it's a triangular prism, we do 1/2 BH. All right. And H, make sure we understand what H, that's the height. Now, I just don't want to say height. It's the height of the prism. All right. It's not the height of the base. It's the height of the prism. And this is where I'm going to start. I didn't do it much in the surface area part because we didn't need it, but I'm going to start getting heated and animated, making sure we all know what the height of the prism is. It's the edge that connects the bases. So if you look at my triangular prism here, everyone see the two triangles. Find an edge that connects them. That's the height. Okay? The height of a prism in BH is what connects the bases. Go over here to my hexagonal prism, right? The bases are hexagons. Pick any edge that connects the hexagons. That's the height. Okay, that is the height. That is how you recognize height of a prism. Find the two bases and find an edge that connects them. That distance is the height. All right, next up, cylinder. Already on your formula sheet. It actually gives you a more detailed version of BH. It's pi r squared. All right, let me stop there. What's pi r squared? That's area of A. Yeah, darn right, because that's a cylinder's base. It's a circle times height. That's BH. That's all that is. That's BH. Except now instead of B, it's got to be pi r squared because it's a circle. All right, so those are the two we're going to focus on today. Any questions about their formulas? Always given to you. All right, get ready to get called on here. This is the number one is the only time I'm going to do find a volume, and that's it. We're done with the problem. All right, these problems are going to get more and more involved. First, name of this polyhedron. Name it. What am I working with here? This is a what? We've had a lot of practice here. This is a, Dylan, what type of polyhedron? Triangular prism. All right, so now volume. We're not doing surface area anymore. Volume, base, times height. Dylan said it's a triangular prism, meaning what shape are the bases? What shape are the bases here, Tess? Triangles. So for capital B, you're going to find the area of one of those triangular bases for me. That's capital B. I'll talk about the height in a second, but let's focus on capital B. Area formula for a triangle. Need that back out. Area formula for a triangle, Bailey. Okay, 1/2. Everyone look at that triangle. What are the base and the height since it is a right triangle? What are the base and height lengths of that right triangle there, Cormac? Good, the two legs. We've discussed this at length. It's the two legs. So 8 times 15. Now the height of the prism, right? That's what H is in BH. Height of the prism, easiest way I can describe it, find an edge that connects the two triangles. And how long is it? Find an edge that connects the two triangles. And what's going to be the height of the prism now? Height of the prism, Brendan? 8, right here, this 8. All right, there's other heights. So, it could have been that 8, could have been that 8. All right, but they're all the same, 8. And I got one more surprise here for you. When you tell me what the volume is, some of you may know this already, maybe not, which is fine. All right, what number do we get for the volume after you calculate it? What number do you get? Brendan, back to you, boss.
480.
480, good. All right, let's talk units now. Surface area, I had square units, right? Well, now we're doing volume. Anybody know how it changes? Because it does. It is not squared, Bailey. What do I do now? Cubic units, cubed to the third. So meters cubed. All right, all your volume now, volume is cubic units. All right, everyone, have fun with that one because that's about as easy as it gets today. We're not going to be finding volume and be done anymore. All right, any questions? Basic volume of this triangular prism. And we didn't even have to do Pythag. Look at us. All right, here we go. 2. Now we're in for it. Ooh, rectangular pool. 1,080. Whoa! Cubic meters. Now, never mind. I do come out and say the volume is. I was going to ask why this is a volume problem, but it says volume. Never mind. If it didn't, though, cubic meters, it's the only time, right? If it's cubic units, it's a volume. You don't have to do you don't have to do a picture of my pool here, but here you go. Here's your pool. Whoop, whoop. There you go. Beautiful. We're almost done with this course, guys. We are almost done. When I have numbers in a ratio, so I can use them in an equation, what have we been doing over and over and over all year long? So I can use them in equation, Bailey. Put an X with them. So everyone see the length is 10? No. The length is 10x. Wherever you want to put that, it doesn't have to go there. The width is not 4, it's 4x. And the depth, the height, x. And this is a rectangular pool, so rectangular prism. All right, ready? Volume, let me start with the formula. Base, area of the base times its height. Hey, that 1080, where do you want to plug it into that equation now? That 1080, where are we going with that? Bailey, over to you again. For the volume, V. 1080, everybody, over here, because that's the volume. Using our terms here, what's the area of the base? What times what here? Do you want me to do area of the base? Area of the base, we're going Stellan.
10 times 4.
10x 10x times 4x. And then the height, distance between them, x. And again, it doesn't have to be that order. You guys are going to figure out pretty quick if you don't know already. Anytime we do a rectangular prism, it's always length times width times height. And it doesn't matter what order we plug them in. All right, everyone, good for the geometry. All right, in a couple months, you got to start doing algebra 2 with somebody else, and I need to do my best to make sure you're kind of prepared for that course. What do I get when I multiply these 3 bad boys? 10x times 4x times x. I got to send you off sooner or later. Oh boy. 10x, 4x, x. Oh, please not me. Please not me. Please not me. Shara, come on, let's go.
40x.
How many x's do you have? There you go. 40x cubed, everybody. Add your exponents. You got 3 of them there. All right, good. Okay, we're getting there. We still have some anxiety going on because I don't know what to do next. I need to get x by itself. Come on, what do you think here? What do I got to boot over? Got to get x by itself. What's moving? What's moving, Bailey? Darn right. Divide by 40. So now I have x to the third. You guys are dividing 1080 and 40 with me and getting 27 out. All right, now I'll take over and teach you a little something because I don't think you learned this at all last year. I don't think, but definitely going to be exposed to it next year. Quick question. If I had squared here, x squared, what are you doing on both sides? Taking the square root, darn right. But now I have x cubed, so we're going to take what's called, take a look. That's a square root, but now we're going to take what's called a cube root there of both sides. And I'll show you where that is on your calculator. So we're going to take the cube root. If that was x to the fourth, I'd take what's called the fourth root, x to the fifth root of both sides. All right, where do I calculate the cube root of 27? You go to your calculator, or basically you can find everything. If you're unsure, calculate, hit your old toolbox. All right, hit your toolbox. And I don't know what some of you, where it's going to bring it up on the toolbox, but you got to go all the way to the very beginning where absolute value is, and then you'll have this right here that says nth root. Make sure you can find that right now in your toolbox. Some of you might already be there because of my last period class, but find it in your toolbox because that's where it is. And that's what you want. I can't do that, huh? So find where it is, the nth root in your toolbox, enter, and now you can type in whatever root and whatever number underneath you need. Okay? So I need a 3 there and a 27 there. And we see x equals 3. Everyone can get there in the toolbox. You know where it is now, in case you need it tonight. All right, x equals 3. Didn't answer the question, though. What are the dimensions of my pool? So take your 3, plug it back in. Plug it. That's why we have 10x, 4x, and x. Plug it back in. So 3 times 10, 30. 3 times 4, 12, and just x, 3. What type of units go here? Should I cube these? Nope, this isn't. This is just length, width, height, so it just gets meters. Not squared, not cubed, just meters. I'm going hardcore. All right, let's go. We got Big Jed. Just bought a generator. Power must be going out, huh? You had enough. Needed to buy a generator. That bad boy can run 2 hours on a liter of gas. Now we're going liters. Oh, just so happens his generator is in the form of a rectangular prism. Lucky us. All right, he's going to fill this tank with gas. How long is it going to run? All right, now look what it runs on. It runs on liters of gas, right? And you see that this is in centimeters, not liters. So I gave you this conversion that we're going to need here in a second. All right, that's why I gave you the conversion. And also, the conversion tells you this is a volume problem. Why? Centimeters cubed. All right, in a month from now, you're going to be taking a Regents, and you have no idea what problem it is until you see, oh, the conversion has cubic centimeters, so it's got to be a volume problem. So first step, let's find the volume of the generator. Go ahead, in cubic centimeters, find the volume of the generator. That's a rectangular prism, base, big B times H. Whew. When you have it, how about that volume of the generator when you have it? So we can fire this thing up with some gas. Whew, here we go. Lauren, when you have it, what do you got? 3,000 square, ooh, almost caught myself, cubic centimeters. That's 15 times 20 times 20, everybody. Sorry, 15 times 20 times 10. How about that? Everyone all right? All right, we got to move on. Hey, this is Not having you do this. I need more. I need more from this part of the unit. We got to find out how many liters of gas now so I can figure out how many hours. And I get it. We had this issue last unit. What do I do with the 1,000? Am I going to divide or multiply? If you know, go do it. All right, go do it if you know, if you multiply or divide. If you don't know, you set up a proportion. I take my conversion, 1,000 cubic centimeters equal to 1 liter. Over. I take my volume, which is in cubic centimeters, put it over the 1,000, and solve for how many liters. All right, if you don't know what to do with the 1,000, I don't care. That's fine. There's nothing wrong with that. Don't be, be ashamed of that. It's fine. But set up a proportion if you don't know. And as you cross multiply, you find out, oh, I should divide by the 1,000 as you cross multiply and solve for x. So as you guys do that, how many liters does this bad boy hold? How many liters of gas? And then we're still not done. Alexi, how many liters of gas? 6. Oh, I think you're giving me the final answer. It doesn't hold 6. Your cross ready? 3,000 times 1 equals 1,000 times x. What do you do on both sides? Divide by 1,000. So it holds 3 liters. All right, everyone else holds 3 liters. Now you got to tell me how many hours it runs. And again, it runs 2 hours for every liter of gas we have. And we have 3 liters here. So third step, find how many hours this bad boy can run. Boom, hours there. Nope. Try again. And third time's the charm. Brendan, what's good, boss?
Oh, 6 hours.
6. I got 2 times 3, 6 hours. Guys, that's what we're looking at right now for these types of problems. All right, no more just finding volume. Anything you want to ask with Jed's generator? All right, you ready for cylinders? A basic cylinder problem before we get tougher. Basic cylinder. Ooh, look at that bad boy. Height of 7 centimeters, so that should be connecting the bases. Diameter of 10. We got that. All right, what's the volume in terms of pi? Volume in terms of pi. Yep, good. We're going back to the formula sheets. We're going back. Again, zero sympathy. You're not using the formula sheet. It's right there given to you. You just got to know what to plug in. Oh, how many are plugging in 10? Come on now. We're looking for radius. Come on now. Come on. 5 squared. And we're just leaving it in terms of pi for this one. Volume in terms of pi when you have it. Oh, going deep there, Simon.
175.5.
There you go. With confidence. Cubic centimeters. That was fun, wasn't it? That was fun. Too bad we're never going to ask that type of question again. Here's what we need. Oh, little thermos. Anybody still bringing those in for lunches? No? Thermos? Okay, yep. Anybody back in elementary, maybe middle school, had the metal lunch box with the thermos that matched the character on the outside? You did. You probably, yep. No? Like the Pokemon lunchbox with the Pokemon thermos inside and everything fit perfectly with your sandwich and the thermos, yeah? Used to flip the top up. Okay, yeah, you can pretend like you don't know, but you do. Anybody want to admit to the character that they had on their lunchbox?
It was SpongeBob.
There you go. The man, the myth. Anybody else? Okay, all right. Yeah, too cool for that. Oh, okay. Yeah. All right, you all had it. All right, so we had a thermos, shape of a cylinder, of course. Looks like we're going to fill that bad boy up with some coffee. But here's the thing, we're not going to fill it all the way up with coffee. We're going to fill it 1 inch from the top with coffee. Oh, did you see that? That magic right there? Oh my God, that finally did it this year. Finally. Let's go. Did it. Ah, that was great. One more. This is like magic. Didn't even have to color it in. Look at that. Look at that. Unbelievable. All right. 1 inch from the top. That just made my day. Could never get to do that this year to fill it in, but now there it is with the coffee. And it looks good. Height of 12. All right. So I got a height of 12. And a radius of 2.5. Read the end carefully. I don't care about the volume of the thermos. I want what volume of coffee is in there. Well, the reference sheet doesn't have volume of coffee. Thanks for the update. The coffee is taking the shape of a cylinder, correct? Because it's in a cylinder. So we're still going to use pi r squared times h. But be careful when you plug in for the height. All right, be careful when you plug in for the height. I am going to use 2.5. That's the radius of the coffee. But the coffee does not have a height of 12 inches, unfortunately. I don't want to use the 12. I don't want to subtract anything either from this volume. I'm going to just find the volume right away. What can you tell me about the height of the coffee now? Height of the coffee, Vinny? 11, because he can subtract 12 minus 1 from the top. 11 inches. Good. Oh, nearest hundredth there too. Look at my rounding directions, getting you guys ready for the regents. Hundredth. 2 numbers after the decimal. Look at the third to round. Oh, Vinny, back to you.
215.98.
Yeah. What do we got? Cubic inches because it's volume. That was great. No, sorry. That's weird that it just does the oval there. No, all right, I'm done. That was great though. All right, moving on. Coffee to oil now. A barrel of oil. Some people have asked me this, and I just want to make sure we go over it as a group. When it says a right circuit, that means it's just standing straight up and down. There's some that do lean. We won't be using any of those. All right, so right circular cylinder, standing straight up and down. All right, what do we got? Diameter of this barrel is 22.5 inches with a height of 33.5 inches. There are 231. All right, here's again. I know it's volume day, but that's how I'm going to know in the future that I have to find the volume, cubic inches. How many gallons are in here? So there's going to be a conversion at the end. But before we do any converting, we got to find the volume. Squared times the height. Not 22.5, right? 11.25 for radius. And my height, 33.5. Quick question as you guys calculate this. Is this going to be my final answer right here that I circle and done? Nope. Why am I asking that to everyone? We are not rounding it. We are not rounding it. So I'm getting 13,319 with some decimals. Now I got to convert that into gallons. All right, now I got to convert that into gallons. Again, I don't know what to do with the 231. Do I add or multiply, divide? If you know, do it. If not, right, we set up 231 cubic inches equals 1 gallon. There's the conversion I gave you in the problem. Over, put your cubic inches under cubic inches, and cross multiply to solve for how many gallons are in this tank. Nearest 10th. How many gallons? Nearest 10th. So after you're done cross multiplying, figuring out what to do. Wow, Vinny, that is unprecedented 3 in a row here.
5.3 gallons. Oh, wait.
I didn't say anything. It's not even close.
Yeah.
Not the first one.
That's good in your book, right? The roast has started. Let's go. Anybody else want to chime in? Get a little piece of this? Didn't think so.
0.2 gallons.
What are you doing in the calculator?
I don't know.
Okay. So that was your volume, right?
Yeah.
Okay. There's 231 cubic inches in every 1 liquid gallon, right? So this is how many cubic inches I have. So you're all right with?
I didn't get that as my number.
Did you do 11.25 squared times 33.5? Did you forget the pi?
Oh, I didn't do it squared.
Okay. Let's regroup. Regroup. You got it. I got faith in you.
Is it? Wait. Hold on. 61.3 gallons cubed.
What are you getting for the volume?
13,000.
319.
398. No, 982. 13,900.
What are you typing in that calculator? Like, is your calculator in English right now?
Yeah, I'll type it in again.
Okay. 10th time's the charm, they say, right?
Yeah. Oh, now I got it. Is it 57.7?
There we go. Yeah, buddy. There we go. 57.7 gallons. Good. It's amazing what you can do when you have the correct volume, right? Okay, now I'm nervous to go on to the next one. Any questions on the 57.7 gallons? All right, here we go. I could have left it out, but we got to get on it. Hexagonal prism. Start with the formula, right off the formula sheet. BH. Height, it's already there. So let's plug in 8 for H. Here's where you're going to need to work. Volume, the area of that hexagon. I feel like we've done this a lot, because we have, but we'll still review it nice and slow. So we're going to find the area of this hexagon. So just let everyone know we're calculating the base here, the hexagon. All right, ready? You guys remember we don't have a hexagon formula. Instead, I draw 6 triangles in. By drawing in all the radii, I find the area of one of them and multiply by 6, right? That's what I do, multiply by 6. So this base was what, 6 inches down here? So far I have 1/2 times 6. The area of that triangle right here. All right, hey, ready for the height now? Because that's where we're going to need our rules. First step, what's the angle I formed right there? 360 divided by 6 of them. That angle is 60. Now, as I draw my height in that I need to find, what's happening to that angle of 60? Good. So there's a 30 here. And even down here now, right, is getting bisected. So that's going to be 3 inches. Here's my 60. All right. What's the height of this triangle now? Across from the 30 is 3. What's across from the 60 using my rules? Shoom, there we go. Jared, what's my rule there? Great job. So 3, radical 3. But don't forget, that's only for one of these 6 triangles. Got to multiply it by 6. To calculate capital B. Bless you. What do we have there? 54 radical 3 for the base? Yeah. Or whatever long decimal you got. Don't round it. Multiply it by 8. And what am I rounding to here now? Nearest hundredth again. All right. All right, nearest hundredth when you have it. Whew, there we go. Let me go another one here. Where are we going? Finley, here we go. There you go. Cubic. All right, so we can find it if it's a hexagon. All right, I'm going to really take hands off. I'll let you work with the people in your group for these. I do have good news now. I know the bad news is the problems are going to get harder in this last part of the unit, but the good news, well, first of all, let's talk quickly. Number 8, if you go back on your reference sheet, it's not going to say volume of an L or a Tetris piece. I hate to break it to you. I don't have that volume formula. What can I do, though? Break it up into 2 rectangular prisms any way you want. Okay, so you'll do that. And then just before you do that, go to number 9. Half a cylinder and a rectangular. Now, remember when we did surface area, we always had to worry about what was covered up? We don't have to worry about that anymore because we're filling the inside up. So we don't have to worry about what's covered up. I don't care that this 6th face here is being covered up by the cylinder. Doesn't matter. You don't have to subtract it out. It's the cube, or that's not a cube, rectangular prism plus half a cylinder, add them together. You do not have to worry about what's being covered up in volume because you're filling it up. So I'm just going to let you guys go. 8 and 9. Let's see what you got. Cut it up however you want. And then number 9, just add the rectangular prism with the half cylinder. that's the radius, right?
Yeah.
Okay, so go over here to your cylinder. From here to here, right?
Absolutely.
Here's radius. Good. Yeah.
Cylinder.
And then remember what we said the height was. The height's the edge that connects. So show me an edge that connects the two circular bases here. Yep, and that would be your height. So can you figure out what that would end up being? Okay, you got it. And cut that. Then go back to that prism one here. Yeah. So you cut that one, right? So you have 6 right here, right? You have 4 on top, so that would be a 4, so that would be a 2, right? So your when your 3's there, it should be a 2, right? And then this one, you got the 8, you got the 2, now look at the 6. All right, let me go over this. Hey, let me go over this. Can I just take a quick poll here? How many of you cut it up going with that vertical line? Not many of you, just me and a couple others. Okay, everyone else did going that way? Okay. 76 cubic feet going that way. Over here for number 9, real quickly. You may have, I don't think there's any issues here. 11 times 6 times 8, right? 11 times 6 times 8. Hey, for the rectangular prism, that shouldn't have been a big deal. Maybe the cylinder was, so you're gonna have to divide it by 2, multiply it by a half. Pi, let's talk radius. Radius is this right here. From here going out, there's the radius. 15 minus that edge of 11. So it should have been 4 squared. And again, I'm going to get animated now. The height is the edge that connects the circular bases. That's the height right there, that edge length, which would be, let's see, out of all the edge lengths I have, 6, 6, that's got to be 6. So that ends up being the height of your cylinder. It's the edge that connects the bases. That's why it's 6 versus 8 versus 11. Okay? Remember, it's not 8. The cylinder's not standing straight up and down here. It's on its side. So you got to find the edge that connects the bases. And here you go. It should have ended up being 679 cubic inches. Okay? Cubic inches. Guys, I don't ask for much here. All right? I don't ask for much. It's only 6 problems. The second part of the unit, there's not much as far as an assignment goes.